This is section 5.6.2, scientific notation. A positive number is written in scientific notation when it is expressed in the form a times 10 to the nth power, where a is a number 1 or greater but less than 10, and n is an integer. Remember that integers can be positive or negative. Let's look at some examples here. We have 5 times 10 to the third. This is in scientific notation. You'll notice that the number 5 is between 1 and 10, and the exponent of the 10 is an integer. Our next example is 2.6 times 10 to the 7th. 2.6 is between 1 and 10, and the exponent of the 10 is an integer. And finally, 1.016 times 10 to the negative 8th. Again, our number out in front is between 1 and 10, and the exponent of the 10 is an integer. In this case, negative. Next, we're going to talk about converting from scientific notation to decimal notation. If the exponent n is positive, move the decimal point to the right n places. If the exponent n is negative, move the decimal point to the left n places. Let's take a look at these examples. We start with 5 times 10 to the third. This is obviously in scientific notation, and we want to convert it to a decimal. Well, notice that our exponent on the 10 is positive. So what that means is we're going to take the decimal point and move it to the right 3 places. Well, you might be asking yourself, what decimal point? Of course, the number 5 right here we can think of as 5.0. So there's our decimal point. Now we're going to move it to the right 3 places because of the exponent on the 10. So we move it 1, 2, 3 places. There's our new decimal point. And we fill in with zeros everywhere there was no number. So we can see that 5 times 10 to the third is the number 5,000. Our next example, 2.6 times 10 to the 7th. Once again, the exponent on the 10 is a positive number. So we're going to move the decimal point in 2.6 7 places to the right. So we have 2.6, and we're going to move our decimal point 1, 2, 3, 4, 5, 6, 7 places, putting zeros in all the new place values. And so the number 2.6 times 10 to the 7th is the number 260 million. Oh, no, excuse me, I have that in the wrong spot. Let me double check that. Here we go. So 2, 6, and then we have 1, 2, 3, 4, 5, 6 zeros. Yeah, 1, 2, 3, 4, 5, 6. There we go. 26 million. 2.6 times 10 to the 7th is 26 million. All right, our last example, 1.016 times 10 to the negative 8th. So in this example, we see that our exponent is a negative number. That means we're going to move the decimal point to the left 8 places. So I'm going to start right over here, 1.016, and we're going to move that decimal point 1, 2, 3, 4, 5, 6, 7, 8 places. Put zeros in all these new places. And you can see our new number is a very small number. And And of course, scientific notation is most often used to express very large or very small numbers in a neater manner. And for example, this last one, 1.016 times 10 to the negative 8 is probably an easier way to express the number that we see here in decimal notation. All right, next we need to do the opposite of what we just did. We need to convert from decimal notation to scientific notation. So in order to do this, we move the decimal point in the given number to obtain a number between 1 and 10. The number of places the decimal point moves gives the value of n. If the decimal was moved to the left, n is positive. If the decimal point was moved to the right, n is negative. You'll remember n is the exponent on the 10. So let's take a look at our examples. We're dealing with the exact same numbers as in the previous slide, but we are going from decimal to scientific notation. So here we go. 5,000. We know 5,000 has a decimal point right there. So we need to move the decimal point to get a number that is between 1 and 10. So if we do this, we go 1, 2, that would give us 50. Back here we get 5. So that's where we want to move it so that we end up with 5.0 times 10, because it's scientific notation. Now we move that decimal point 3 places back to the left. And we know that if we move it to the left, that our exponent n will be positive. So the exponent here will be a positive 3. So we have 5.0 times 10 to the third. Our next example, 26 million. We know that we have a decimal point at the end of this number right here. So we're going to move that decimal point until we get a number between 1 and 10. So we have 1, 2, 3, 4, 5, 6. That would give us the number 26, but that's not going to work. We move it one more time, 7 places, to get the number 2.6. So we have 2.6 times 10 to the, we moved it 7 places to the left, so again that's going to be a positive 7 exponent. 2.6 times 10 to the 7th. And our last example. As you can see, we have the very, very small number here, and instead of rewriting that, I'm just going to move my decimal point from here and end up with a number between 1 and 10. So we have 1, 2, 3, 4, 5, 6, 7, 8. If I move it to right there, I'll have the number 1.016. And I moved that 8 places to the right, so if it's moved to the right, the n is negative. So we have 1.016 times 10 to the negative 8th for our last example there. All right, next we're going to talk about multiplying numbers in scientific notation. Use the product rule on the tens and multiply the other parts of the numbers separately. All right, so if you should be familiar with the product rule. Of course, with the product rule, anytime we multiply with the same base, we add the exponents. So let's put this to use here. Our first example is 3.4 times 10 to the 9th times 2 times 10 to the negative 5th. So we would use the product rule on our tens here because we're multiplying those together. 10 to the 9th times 10 to the negative 5th, we would add the exponents. 9 plus negative 5 would be 4, so we get 10 to the 4th. And then we multiply the other parts. 3.4 times 2 is 6.8. So we have 6.8 times 10 to the 4th. Now it's always important that you double check that this number is between 1 and 10, because if it's not, you're going to have to make an adjustment to your scientific notation. All right, our second example, 1.3 times 10 to the 7th times 4 times 10 to the negative 2. So let's start out by using the product rule with our tens. 10 to the 7th times 10 to the negative 2. We add the exponents. 7 plus negative 2 is 5. So we have 10 to the 5th. And now we multiply 1.3 times 4. 1.3 times 4, if you need a calculator, you can certainly use one. 6.2. So we end up with, or excuse me, not 6.2, but 5.2 it should be. 4 times 1 is 4, and then plus 1 is 5, 5.2. All right, so we have 5.2 times 10 to the 5th. Once again, you want to make sure that this number is between 1 and 10, and in this case, it is. So we're good to go. All right, let's look at our last example here. 5.7 times 10 to the 3rd times 4.2 times 10 to the 4th. So we will start with our tens again. 10 cubed times 10 to the 4th, that gives us 10 to the 7th using the product rule. 5.7 times 4.2, again, you can grab your calculator, is 23.94 times 10 to the 7th. All right, now in this example, you will notice that this number is not between 1 and 10. So we have to change our scientific notation a little bit here. We need to move the decimal point that you see right here so that we have a number between 1 and 10. And of course, if we move this decimal point back here, 1 to the left, we're going to end up with 2.394 times 10 to the, now, if we move that back to the left, remember moving it to the left made it positive, so what was 7 is now going to be 8. So 2.394 times 10 to the 8th is your answer. All right, finally we're going to talk about dividing numbers in scientific notation. It says use the quotient rule on tens and divide the other parts of the numbers separately. Again, the quotient rule says that when you divide with like bases, you are subtracting your exponents. So, in our first example, 8.4 times 10 to the negative 7th divided by 4 times 10 to the negative 4th. So I'm going to use the quotient rule right here. Negative 7 minus a negative 4 is the same as negative 7 plus 4, which ends up at negative 3. So, we're going to end up with ten to the negative 3rd. All right, next we have to do 8.4 divided by 4. 8.4 divided by, divided by 4. Well, 4 goes into 8 twice, and 4 goes into 4 once, 2.1. So we should have 2.1 times 10 to the negative 3rd. Our next example, 6.9 times 10 to the negative 8th divided by 3 times 10 to the negative 2. So, use the quotient rule on the tens. We have negative 8 minus negative 2. That's the same as negative 8 plus 2, which is negative 6. So we're going to have 10 to the negative 6th power. And 6.9 divided by 3, that'll give us 2.3 times 10 to the negative 6th. And of course, remember, you can use your calculator to do 6.9 divided by 3. if you can't do that in your head or if you can't do it on your paper. So you have 2.3 times 10 to the negative 6 there. And of course, you always need to make sure that these numbers are between 1 and 10. If they're not, you'll need to adjust the decimal point as well as the exponent on your 10 to make it correct scientific notation. This has been section 5.6.2 on scientific notation.